In this video, I'm going to go over quite a few different graphs. Before we get to the actual graphing aspect of it, let's talk about what the formula is and what each of those components of the formula means. So, general sinusoidal graphs. We have two general forms, and that's cosine and sine. And so if we're looking at a sine function, we're going to have something in the form of y equals c plus a times sine of b times theta minus d. So that's just the general form for it. This can be written differently. The c can be added to the end or subtracted in the end, and it still means exactly the same thing. So now, as we look at each component of this, if we're looking at A represents your amplitude. And amplitude is the distance away from the sinusoidal axis. So specifically, we're looking at the absolute value of A, meaning that we don't care if it's positive or negative. The amplitude is just the absolute value of it. And so I'm going to write next to this that it's the amplitude. And then I'm going to kind of describe what that means. And so that is half the distance from the min to the max, or it's the distance from the sinusoidal axis to the max. So that's just a couple of different ways to look at that. And I'll draw a picture out so that you can see what I mean. Or distance from, I'm just going to write axis to max. So that's just two different ways to look at it. B, and again, we're going to be looking at the absolute value of B. Sometimes B could be negative. This technically is the reciprocal of the horizontal dilation, but that sounds kind of weird. And so B really is the number of cycles that fit within a normal period, and we use B to find our period. So we use B to find our period, and that's 360 degrees over B equals our period. And again, I'll show you what all of this means. C is where our sinusoidal axis is. It's also called the vertical shift or vertical translation, whatever you like. There's a lot of different words that we can use here. And lastly, we have D, and D represents our phase shift or our horizontal dilation. So in trig, we use the word phase shift, but if you think back to any other function that you learned, this is just our horizontal shift. So let's just draw the parent function of sine so that we can put all of this together. So our parent function of sine, and if you have a hard time remembering this, it comes from the unit circle. So if you look at your unit circle, you can pull all of these values, but our parent function of sine has a period of 360 degrees. I'm going to show you two full periods, so I'm going to put 360 right here. Now, every function can be broken into 4 different parts, and so since it can be broken into 4 different parts, we're going to do 360 divided by 4 to tell us what our different increments are. And so we're going to go 90 degrees, 180 degrees, 270 degrees. And this is our parent function. And then this would be 720 degrees because that's the second full period. And we can always extend it backwards as well because it's periodic. We're going to go up to 1 and down to 1 because if we think about the unit circle, the highest value is 1. Now sine starts at the sinusoidal axis. Then it goes up to its max, and that's 1/4 of a period. So 1/4 of a period is 0 to 90 in this case, and it goes all the way up to its max. The next fourth of the period is it coming back down to the sinusoidal axis. So that's another 1/4 of the period. The next 1/4 of the period is going down to the minimum. And the last 1/4 of a period is going back to that sinusoidal axis. So there's 4 parts of one period. Now, because it's periodic, we can keep doing this over and over again forever. And you follow all 4 parts. Max, sinusoidal axis. Min, sinusoidal axis. And you can just keep on going. And you can go either direction. So we have 4 different parts here. And that creates 1 full period. So this is 1 full period right here. Now we talked about the amplitude. The amplitude is the distance from the sinusoidal axis up until the max. So the amplitude for the parent function is 1. So that's the distance there. Our b value for the parent function would be 1 because it's 360 over b is your period. Our period is 360, so 360 over 1 gives you the period of 360. And then our phase shift is where we are actually starting. Now, periodic functions, they can be written as sine, they can be written as cosine, they can be written as negative sine or negative cosine. And depending on how you shift it, that's going to allow you to choose that. So, that's just kind of the general information, and then we will do a couple of examples. Alright, so what we have here is we have a graph of a sinusoidal function, and we want to find the particular equation for this. So to find a particular equation, we have to do quite a few things. 1, we have to figure out, are we going to use sine or cosine? 2, we have to find our amplitude. 3, we have to find our phase shift. Then we have to find our vertical shift, and we have to find our period. So I like to start by just writing all of that off to the side, because I think that helps me figure it out, what I'm going to do. So the first thing that I notice is that my closest point to the y-axis is this maximum. So that maximum is my closest point to the y-axis. And if that's my closest point to the y-axis, that's what I'm going to use for my function. Now we're starting at a maximum. So if we're starting our function at a maximum, that means we're going to use a positive cosine function. So that's just going to be the first thing that I write, is that I'm going to use a positive cosine function because we're starting at that maximum. The next thing I like to do is find my amplitude. And the amplitude is half of the distance from the sinusoidal axis to the maximum, or it's half of the distance from the minimum to the max. So it looks like our minimum to our maximum is 3 to 15, which is 12. And so half of 12 is 6. So my amplitude is 6. And that represents this distance right here. So my amplitude is 6. The next thing that I'm going to find is the period. So the period is calculated by finding when it's exactly in the same spot again. So we start here, it's exactly in the same spot again here. So we started at 20 degrees, we're ending at 200 degrees. The difference between that is 180 degrees. Now we use that to find b, because remember, if we're using a cosine function, we need to fill in these blanks here. C plus a times cosine of b times theta minus d. And b is 360 over our period. So if our period is 180, then our b value has to be 2. 360 divided by 180 is 2. Now I'm going to find my phase shift. And my phase shift, because I'm starting right here, is going to be 20 degrees. Vertical shift or vertical shift or sinusoidal axis is the next thing that I need to find, and that's what this line is here. And if I know that this distance is 6, because we found our amplitude to be 6, 3 plus 6 is 9. Now we have enough information to write an equation. So if I were to write this equation, I'm going to plug 9 in for c, so I'm going to have y equals 9 plus a is 6 times cosine, b is 2 of theta minus 20 degrees. I'll highlight where I got each of those values from. So this is our a value. This is our b value. This is our c value. And this is our d value. Now, I always like to double check myself because I have a really cool calculator. So if I go into my calculator, the first thing that I'm going to do is set my scales to look similar to that. And if that's the case, I'm going to go to Window. I'm going to start at negative 70 degrees. And I'm going to go up to 200 degrees. And I'm going to go up, well, they go up by crazy numbers, but let's go up by 20s. And then I'm going to go from 0 to 15. Make sure my calculator is in degree mode, and I can go ahead and plug this in. 9 plus 6 times cosine. Now here's when things get a little bit tricky. We're going to have 2 sets of parentheses. This is technically inside of here. So when you plug it into your calculator, plug it in like that. 2 times x minus 20. And now we can hit graph. And does that graph match up? Well, we are going up by 20, so it looks like it is there. And then this would be 200, and that's where it is. So I would say yes, we did a good job. We got it to map up, and that's our equation. Cosine was not the only equation that you could have used. You could have started here, and you could have used a sine function. You could have started here and used a negative cosine, or you could have started here and used a negative sine. Really, it's your choice what you choose. I like to choose the one that has the least amount of displacement. Okay, so we have another graph here. And again, we are going to write an equation for this. And so we want to figure out what function are we going to use, what's our amplitude, what's our period, what's our phase shift, and what's our vertical shift. So I always like to start by figuring out what equation am I going to use. So you can use sine, cosine, negative sine. And so our options are we could start here, we could start here, we could start here, or we could start here. And they were really nice, and they actually gave us what each of these values are. We've got negative 6, we have positive 4, 14, or 24. I like to start where I have the least amount of displacement, but that doesn't mean that that's necessarily right. So the least amount of displacement here would be 4 degrees, and if that's the case, I'm starting at a minimum. If I start at a minimum, I'm going to use the negative cosine function, and so my general equation is going to be c minus a times cosine b theta minus d. That means that I need to solve for my sinusoidal axis. I need to solve for my amplitude. I need to figure out what b is by finding my period. And then I need to find my displacement. Now some of these you can see right off the bat. The displacement you already know is 4 degrees. That's why we chose it. Okay? So let's go ahead and solve some of these things. So if we were to solve for c, c is where that sinusoidal axis is. that's this line here. And that line is half the distance from 18 and negative 2. So negative 2 plus 18 is 20, which means that it's 10 away. So this has to be 10 away, this distance. So where does that put this line? I need to think about it. Hopefully you got that puts the line at 8. So our sinusoidal axis is at 8, and that's what we call our vertical shift. So I'll highlight that in yellow so that you know where that came from. And you know what? I'll even highlight the line in yellow. Okay. A is our amplitude, and we actually just solved that the amplitude is 10. It's half of the distance. And so what we did, so I'm going to put amp right here so that we know. We did 18, that was our max, minus our min, and we divided that by 2. So max minus min divided by 2. And we got that our amplitude was 10. Okay? So we have C and we have A. Now we need B. And B comes from our period. And so I'm going to write period here. So we started right here. The next time we're in exactly that same position as here. 4 to 44 is 40 degrees. So our period is 40 degrees. And we find our B value by doing 360 divided by 40. That gives you 9. So that is B. And then we already figured out D, and so we're ready to write our equation. Y equals 8 minus 10 cosine 9 times theta minus 4. Now that's not the only equation that we could have written. We could have wrote this equation as if it was a negative sine function. We could have written it as if it was a positive sine function or a positive cosine function. These numbers will all stay the same. This is what will change if you decide to change that function. Let's do one more example before we start going into half periods and quarter periods. So, again, we always want to figure out what function are we going to use, what's our amplitude, what's our period, what's our vertical displacement, and what's our horizontal displacement. So let's first figure out what function are we going to use. Now, this scale only gives us 2 numbers, which means really we only have 2 choices. We can start here, and if we start here, it's going to be a positive sine function because it's starting at the sinusoidal axis and going upward. Or we can start here, and in that case it'd be a negative sine function because you're starting at the sinusoidal axis and going downward. 2 has less displacement than 8, and so I'm going to say let's use a positive sine function and use a displacement of negative 2. So if that's the case, we're going to have y equals c plus a times sine of b theta minus d. We already know that d is negative 2 degrees. A negative and a negative makes a positive. Keep that in mind. So since we already know that, we can figure out the rest of the stuff. So C is our sinusoidal axis, and that was really nice of them because they gave it to us. They said this is negative 30. So we can already write that in there. Y equals negative 30, and on here I'll write negative 30, just so we have it written down. Then we need to find our amplitude, and remember, amplitude is the distance from the sinusoidal axis to our maximum or to our minimum, but it's half of the total distance. And so that's 10 degrees, or not 10 degrees, sorry, just 10. So we can have plus 10 sine B. How do we figure out B? B is from our period, right? So it's 360 over our period. So we need to figure out a full period. So if I start here, at 8 I'm not in exactly the same position. It's not until here that I'm in exactly the same position. But it doesn't give this value to us. But let's think about this. This is exactly half of a period, and this distance is 10. So that means this full distance would be 20. So 360 divided by 20 is 18. So we'll put 18 here, and then we know that this is going to be theta plus 2. And again, I can go through and I can highlight all of these just so you can see exactly where they came from. And that is where we got all of our numbers from. In this question, we are given half a period. So from 3 to 5, we have gone half of a period. And so we could extend this either direction. We know our sinusoidal axis is going to cut this exactly in half. And if it's a half of a period, this is our max, and this is our min. And we know it's half of a period because it told us in the question half a period, or half cycle. So if half of a cycle is 3 to 5, that's 2 degrees. So what would a full period be? 4. So our period is 4 degrees. Okay, just like every other question, we have to figure out what type of function are we going to use. Now our first point is here. This is a minimum, and so I would say we're going to use a negative cosine function. So, using a negative cosine function, we need to fill in all of these blanks. C is our sinusoidal axis. And so what is exactly in between 50 and 20? And I think it's 35 is exactly in between there. So our sinusoidal axis would be at 35. And that's called our vertical shift. Our amplitude is the distance from our sinusoidal axis to our maximum. So our amplitude, we can find that by doing 50 minus 20 divided by 2. And we get 15. We're almost there. To find B, you do 360 over your period. So 360 divided by 4 gives us 90. So 90 degrees. And then the last thing that we need to do is find our phase displacement. So our phase displacement, we started at the minimum, which was 3 degrees. So our phase shift is going to be 3 degrees. Now we have enough information to write this down. Y equals 35 minus 15 cosine 90 theta minus 3. And there is this function. So the difference here is that when you're given a half cycle, you're going to want to make sure that you remember to multiply it by 2 to get your full period. And then just keep in mind that they didn't give you that whole cycle, so you can continue it because you know how it should go. So this one's the last example I'm going to do with you, and this one is a quarter cycle. And so if it's a quarter cycle, and it gives us 130 degrees here, a full cycle would be 130 times 4. So 5